You cannot wire a 400-watt metal halide high bay fixture directly to a 4-square box with 12mm2 metal-clad cable for several critical reasons. Firstly, overcurrent protection is a primary concern. The 12mm2 metal-clad cable is typically rated for a maximum current of 20 amps. While a 400-watt metal halide high bay fixture draws approximately 3.3 amps, the cable's overall rating and the potential for inrush current during startup make it unsuitable as the sole conductor. Secondly, conductor size is also a factor. The 12mm2 metal-clad cable has 2 conductors rated for 20 amps each. However, the 400-watt metal halide high bay fixture requires at least a 14 American wire gauge conductor, or larger depending on the specific installation conditions and voltage drop calculations, which might not be adequately met by the 12mm2 metal-clad cable, especially when considering the length of the run. Thirdly, National Electrical Code violations would occur. The National Electrical Code requires that electrical fixtures be installed in accordance with their marked ratings and instructions. A 400-watt metal halide high bay fixture is not designed or approved for direct connection to a 4-square box using 12mm2 metal-clad cable. This is because the junction box and wiring method must be appropriately sized and rated for the fixture's voltage, current, and operating temperature. Fourthly, there is a significant fire hazard. Overloading a cable or conductor with excessive current can cause it to overheat, potentially leading to insulation breakdown, arcing, and ultimately a fire. Using 12mm2 metal-clad cable with a 400-watt metal halide high bay fixture creates a fire hazard due to a risk of exceeding the cable's ampacity. To safely wire a 400-watt metal halide high bay fixture, one should use firstly a 4-square box with a half-inch knockout, or larger if necessary to accommodate the required number and size of conductors. Secondly, use appropriately sized conductors, typically 12 American wire gauge or 14 American wire gauge depending on the specific fixture requirements, circuit length, and voltage drop calculations. The conductors must have suitable insulation for the application, such as type THHN or THWN, rated for the appropriate temperature and environment. Thirdly, provide proper overcurrent protection. This typically involves installing a dedicated circuit breaker or fuse in the electrical panel that is rated for the ampacity of the conductors and the requirements of the fixture. For example, a 15 amp or 20 amp circuit breaker might be suitable depending on the wire gauge and local codes. It's important to consult the National Electrical Code and local electrical codes to ensure compliance with all applicable regulations and safety standards. Additionally, always energize the circuit before working on any electrical wiring or connections. It is important to check the voltage rating of the ballast inside the high bay fixture, whether it's 120 volts, 208 volts, 240 volts, 277 volts, or 480 volts, and connect the appropriate voltage feed. The size of the conduit should also be carefully considered based on the number of conductors and their gauge, referring to the National Electrical Code tables for proper fill calculations. Before connecting the fixture, ensure all wiring is properly grounded by connecting the grounding conductor from the supply circuit to the designated grounding terminal in the fixture's junction box. Also, use appropriately rated connectors and fittings for all wiring connections to ensure secure and reliable electrical connections. Always verify the tightness of all connections to prevent loose wires, which can cause arcing or overheating. When mounting the high bay fixture, ensure it is securely attached to the building structure using appropriate hardware and mounting methods as specified by the fixture manufacturer. This may involve using chains, cables, or other suspension systems rated for the weight of the fixture. When working with metal halide high bay fixtures, it is also essential to consider the lamp's end-of-life characteristics. Metal halide lamps can sometimes exhibit a phenomenon called non-passive failure, where the lamp continues to draw current even after it has failed. This can lead to overheating of the ballast and other components. Therefore, it's essential to use metal halide ballasts that are designed to detect and shut down in the event of a non-passive lamp failure. These ballasts typically have a built-in end-of-life protection circuit that will automatically disconnect the lamp from the power supply if it detects an abnormal current draw. Furthermore, it's crucial to follow the manufacturer's recommendations for lamp replacement. Metal halide lamps have a limited lifespan and should be replaced before they burn out completely. Regularly inspecting the lamps for signs of degradation such as discoloration or flickering can help identify when a replacement is needed. When replacing lamps, always use the correct type and wattage as specified by the fixture manufacturer. Using the wrong lamp can damage the ballast or create a safety hazard. In addition to the electrical considerations, it's also essential to consider the environmental conditions in which the high bay fixture will be installed. If the fixture will be exposed to moisture, dust, or corrosive substances, it's essential to use a fixture that is specifically designed for those conditions. These fixtures typically have a sealed enclosure to protect the electrical components from the environment. Furthermore, consider the ambient temperature in the area where the fixture will be installed. Metal halide lamps generate a significant amount of heat, so it's essential to ensure that the fixture is properly ventilated to prevent overheating. Some fixtures are designed with built-in heat sinks or cooling fans to help dissipate heat. Also, ensure that the fixture is installed in a location where it will not be exposed to direct sunlight or other sources of radiant heat. It is also important to ensure the correct input voltage matches the voltage requirements of the metal halide ballast. Connecting a 120-volt ballast to a 277-volt supply, for example, will immediately damage the ballast. Conversely, supplying a lower voltage than required will cause the lamp to not start or flicker dimly. You must verify the ballast voltage and ensure that the supply voltage matches that requirement. Furthermore, ensure the wiring polarity is correct by connecting the black wire to the line side of the power source and the white wire to the neutral side. Incorrect polarity can cause malfunction or damage to the ballast. The grounding conductor should be properly connected to the fixture's grounding terminal to provide a path for fault current in the event of an electrical issue. Regularly inspect the wiring connections to make sure they are tight and free of corrosion. Loose connections can cause arcing, overheating, and potential fire hazards. Look for signs of damaged insulation, frayed wires, or discoloration, which may indicate overheating. If any damage is found, the wiring should be repaired or replaced by a qualified electrician. Verify that the high bay fixture is properly supported and secured to the building structure, ensuring that it cannot fall or pose a hazard to personnel. The mounting hardware, such as chains, cables, or brackets, should be rated to support the weight of the fixture and be in good condition. The location of the high bay fixture should be carefully considered, taking into account factors such as ceiling height, clearance, and accessibility for maintenance. Fixtures should be located in areas where they will not be subject to physical damage or obstruction, and where they can be easily accessed for lamp replacement and cleaning. Furthermore, high bay fixtures should be installed in accordance with the manufacturer's instructions and all applicable electrical codes and regulations. Always consult with a qualified electrician to ensure that the installation is safe and compliant. Additionally, it is critical to properly dispose of the old metal halide lamps in accordance with local environmental regulations. These lamps contain mercury, which is a hazardous substance and must be handled properly. Many municipalities and retailers offer recycling programs for fluorescent and metal halide lamps. When installing and maintaining high bay fixtures, it's important to use appropriate personal protective equipment such as safety glasses, gloves, and a hard hat. Working at heights can be hazardous, so it's crucial to take precautions to prevent falls. Use a stable ladder or aerial work platform, and ensure that the area below is clear of obstructions. Furthermore, be aware of the potential for electric shock and take steps to avoid contact with energized parts. Always de-energize the circuit before working on any electrical components. If you are not qualified to perform electrical work, hire a licensed electrician. When selecting high bay fixtures, consider the energy efficiency of the fixture and lamp. Metal halide lamps are less energy efficient than newer technologies such as LED. Consider replacing existing metal halide fixtures with LED fixtures to reduce energy consumption and lower operating costs. LED high bay fixtures offer several advantages over metal halide fixtures, including longer lifespan, lower energy consumption, and improved light quality. They also do not contain mercury, making them more environmentally friendly. Additionally, LED fixtures typically have a lower operating temperature, which can help reduce cooling costs. When upgrading to LED high bay fixtures, it's important to choose fixtures that are compatible with the existing wiring and electrical system. LED fixtures may have different voltage and current requirements than metal halide fixtures, so it's important to ensure that the electrical system is properly configured. Finally, it is imperative to be aware of any changes or updates to the National Electrical Code or local electrical codes that may affect the installation or maintenance of high bay fixtures. Electrical codes are constantly evolving to address new technologies and safety concerns, so it's important to stay informed of the latest requirements. Consulting with a qualified electrician or electrical inspector can help ensure that your installation is compliant with all applicable codes and regulations. Remember to always consult with a licensed electrician for any electrical work, as they have the training and experience to safely and effectively handle electrical systems and equipment. Ignoring safety precautions and code requirements can lead to serious injury, property damage, or even death. Additionally, be sure to keep accurate records of all electrical work performed, including permits, inspections, and wiring diagrams. These records can be useful for future maintenance or troubleshooting. By following these guidelines, you can ensure the safe and reliable operation of your high bay lighting system.